Exception handling in Python involves intercepting errors during the execution of a program and taking corrective or alternative actions rather than letting the program crash. This is done using try exception blocks. Let's start off with a basic example. First, we create our try block. So we have our try statement, and inside that code block is where we want to try to execute some kind of code that could potentially fail or some kind of error could pop up. So here we're going to try to we're going to assign the result of a division of 10 divided by 0. Now technically you can't divide 10 divided by 0 because then a problem will occur. As a matter of fact, we can quickly do that. If we try doing that, we get a division by 0 error. So we go back and we create our try block. This is where we will try to execute this block of code. And then we have an except where we want to catch that exception. And here we have a 0 division error. And this is the specific error that we want to catch. The 0 division error. And here we could handle that accordingly. And we can do that by printing some kind of information that you can't divide by 0. And if we run this, then instead of having an error pop up or crashing our code, we handle that gracefully and we print that some kind of information letting us know that we cannot do that. A single try block can handle multiple exceptions, which can be useful for reacting to different error types appropriately. So, for example, we could add another except here, where we are trying to catch the value error, and we can handle that appropriately by saying, please enter a valid integer. And if it doesn't catch the first one, then we could catch the second one. If you are not sure what type of error might occur, or you want to catch all possible errors, you can use a generic exception handler. However, this is generally discouraged unless absolutely necessary, as it can make debugging difficult. So let's try to create some basic try block, and where we try to do some kind of complex logic. And we're going to try doing something like string 10 plus the number 10. And we are going to try to catch that exception as E and print that error. And when we run this, an error occurred. You can only concatenate string to string. So this catches all general exceptions, all types of exceptions, so you don't have to provide a specific exception, and you could handle that accordingly. But like I mentioned before, it can be difficult when debugging because anything could basically happen. You can use an else clause in your try except block. The code inside the else block runs if the try block did not raise an exception. So let's create another try block here, and we're going to print trying to divide. Then we will try to divide by 10 by 2. Then we have our except 0 division error, then print division divided by 0, then else print division successful, the result. And so when we run this, we get trying to divide, so it runs this block. Of course, no errors occurred, so then it skips over to the else and it executes this else as well, since there were no problems with the division. And if we try to divide by 0, then we get the exception error. Then we have a finally clause will execute as the last task in the try except block. It runs whether or not an exception is raised and is often used for cleanup actions. So let's create a new try block, or try, and we will try to open a file. And we'll try to read it. Of course, this does not exist, but let's pretend that it does. Then we will read that into our file content. Then we will have an exception or file not found error. And we will print file not found. And then we will have a finally, where in the finally we will close the file and print file closed. So in this situation, we won't be executing this because we do not have a file.txt. But what would happen here is that if this file did exist, then we would read the contents, and if nothing bad occurred, then we would skip over to the finally block and close it, and then print out that it was finally closed. This is generally like to do the cleanup action. So whenever we open a file, it's always good that we close this so that we don't corrupt the file later. So it's always nice to remember that we need to close the file in the end. So these are the kind of situations where we would use a finally clause. You can also raise exceptions intentionally with the raise keyword. This is often done to enforce certain conditions within functions. So let's try creating a new function that checks the age. So let's create our function called checkAge, and we will be providing our age. Then if the age is less than 18, then we could raise an error where the error would be a value error, and it could be access denied, you are too young, and then print access granted. And so now we have our try block, and we will do a check age, and we'll try to check age when it's 15. And we'll have an accept, where we will try to catch a value error as E, and we will print that error. And so when we run this, we can see that access is denied, you are too young. And so when we go into this function, we try to provide the age as 15. 15, of course, is less than 18, so we enter into this block of code, and we use the raise to intentionally raise this error, and we provide a custom error message with that value error. And so that value error is then used as E, and then we print out that message. So here we intentionally raise that error for these kinds of situations. Become a member at AILearningHub.io and get access to personalized mentor guidance, early access to AI resources, help with AI projects, and a great learning community.